Hello, my name is Wahid Lutfi, and today is my vacation day. Actually, I'm just here to serve you. What better way to just celebrate a vacation or enjoy a vacation day than program? People say programmers or developers have no life. To some degree, that's a kind of um, yeah, it is. It is what it is. But you know one thing that when you serve people, you're like what I'm doing this one, it is very, very enjoyable. So without the further ado, I'm going to just make a video for you to help you out with NumPy module of Python. So if you're a student or you're working on a job and you need some more help, you should watch these videos that people make on YouTube channels or other places, and they're all for free. And start learning, especially if you're going to college and you need to do your homework and get better as you progress through your career. So let me just share my screen first of all. And as you can see here, I'm just going to show you the NumPy module, which is numpy.org website. And this is the NumPy module that is the entire page on the website show you how to use NumPy module within Python. And Python website also has a lot of documentation. Aside from numpy.org website that I just showed you, you can also go to Python and go under documentation and look for what you're looking for. Unfortunately, some of the documentation that might be there is kind of hard to just pinpoint what you're exactly looking for. So your friend is here is the website of numpy.org, where they have a lot of documentation for NumPy module itself. So it's very, very intuitive, very easy to do. Similarly, on the Python docs website, you can do it. I always use docs.python.org or and the module itself or the command line syntax from the interpreter itself. You can get that one also. Once you load the NumPy module, which I'm going to show you tonight also, so you can get this kind of information. So for the tonight discussion, I already started Jupyter Notebook on my computer. And then this is the session that I'm going to introduce you. But before that one, let's go to the slides for the nice presentation that you can generate using Google Docs slides. If you're not familiar with how to do a PowerPoint or slides on your computer because you don't have Microsoft Office, you can just log into your Google account and everything is provided for you for free. You can just always create slides, PowerPoints, and any the Word document. So here's a Word document or PowerPoint document in this case that I just generated for this one. It's only 3 pages because I'm going to show everything on the actual Jupyter Lab notebook. So I'm going to do a slideshow here first to show you what we have on tutorial number 3. So it is a Python NumPy module, and it is a tutorial number 3. In order for you to just look for tutorial 1 and 2, which I already posted those ones, you should look at those ones first because it introduces NumPy and it has tutorial 1 and then tutorial 2, it introduces about 6 methods and all those details. And then this one is going to be talking about the NumPy methods and attributes. That's what I'm going to cover tonight. Not all of them, but some of them, a few of them. In particular, I'm going to just discuss some of your options when you're looking at NumPy versus other data structure like NumPy module versus a list data structure. Because usually people compare list against the arrays, and then that's what I'm going to do tonight. So you will see the differences as well. and there. So, and the discussion that I'm going to do is here, we're going to just say the array methods, the info method, the NumPy methods, and then we're going to talk about array objects and attributes, list to arrays conversion and arrays to list conversion, and then more to come. And then obviously I'll thank you at the end, but let's get started with the actual presentation for tonight. So here I'm going to take you back to this session, which is the actual NumPy Jupyter Notebook commands and scripts that I have written already, and I'm going to test these ones. So, and the first one on this one, and when I say import NumPy as NP, this line, it is basically I'm getting the NumPy modules here. And then if I do a dir on this one, dir of this objects here, and then I say, go ahead, print dir of this. You can see before executing these statement, let me just do this. And now you can see dir is just telling you, let me just do print dir of the entire thing. So without the directory listing of NP. So this is all the list of directories that are loaded in Python, and one of them is NP. There, right here. So one of them is NP, and then now let me just remove that line. We don't need it. You saw what it is, and then I'm going to just rerun this one, and then this time I'm going to show you what this list data structure X that I create a list comprehension, and what does that do? So here X is saying that X for X and range of 10 numbers, if X is mod 2 is equal 0, the remainder is 0 is equal 0, that means that we are only generating the even numbers between 0 to 10. So this is why it is printing. When I say print X, here it is printing this statement here, 0 to 8. And then we look at the type of it. The type of it is saying that it's a class list. Class list right here is the type of it. Then we're also doing a conversion of this one. So the list has those 0 through 8. And now we're doing on line 3 is saying on this line, we're doing NP, which is NumPy that we declared here as the alias, NumPy.array X. X is the list. We get a list as an argument to the method array, and then it just generated now a type of array data structure. So this is just array data structure. Notice the difference between the first output versus the third output, which is the array. The list output has a comma, and they're saying that class type is a list. The second output, that is the A, which is an array, it is 0 to 8 without the comma, and it is a type of it is called class NumPy ND array. ND means a number of dimension. Is it one single dimension or multi-dimension array? If it is 2-dimension, it will show you by printing the A dot shape and other attributes. So we're going to go over those ones as well. And then let's go down here. And just looking at this line, we printed A. So A is this, and then we printed the type is telling us now I want to convert the NumPy array back to the list. Here we just took the list as an argument and we generated an array. Here we're doing a conversion of an array, which is a NumPy array object. We're going to just pass it to a list class. Then a list is going to convert it to x2 as a list. And so now you can see that this class, when I printed type of x2, it is class list. Similarly, the value of print 2, you can see it's 0 through 8 a list. Be very careful. This is not the same as this. If you just did a list like this, A to convert it to assign it to X. This is a NumPy operation that is saying that assign this array and declare a new array of list. I mean, array of array. So here, notice that X2 is a NumPy array versus the other one. So if I just want a list of out of it, I need to just use the list class or methods in this case, and then just say the list. This is just basically um, the constructor. The constructor A is going to take, or class A is going to run, and then it's just going to just assign it to a list. And like I said, if you are writing code, make sure that what you intend to do, you're just reading it properly, so you don't just miss the list A and then you assume that X2 is going to be a list rather than an array. If you wanted an array, just write it like this. And then there's also method like copy, also. So you can do numpy.copy and then just make a copy of A. That will also just make it a n-dimensional array. There's a number of ways you can do it, but in this section, I wanted to do a list and then A, so I could show you the conversion between an array back to the list. And here we used um, list as an argument to np.array method, and then we get an array back. So this is what this one does. So let me minimize this window, the output, and I'm going to show you this is a for statement. So since X is a type element of, if I just say print type of any element that I do, since X is a list, I'm going to just run this one and then say, go ahead, run it. Now notice that when I did print type X, X is a list. So then I just want to say, oh, okay, if I just want to get the print of X, the value of them, and then see it, now this is 02468. And then notice that I want to print for item in X, which X is the list, and then print the item, and then the word type, and then the actual type. So notice that 0 is type of int. All of them are type int, even though it's a list, but because we just assigned the list to be a list of comprehension based on numbers, it just printed out the type numbers. But list is not like arrays. They have data type for each item that could be um, string, could be numbers, could be floating points, could be anything. Like in this list 2 that I'm doing here. So let's just print it first here. Print L2. And then when we run this one, let me minimize this window, move this window up, and then I'm going to just run this one. Notice that when we print this list, the 100 as a number is a integer, as you can see, but 100 within the code, the single code is a class string, and so does other ones. If I just change this one like a pair, look at the pair is double coded. Whether you do single code or double code, that's in Python automatically considered as a string. So you can see that when I'm doing the for statement here, this time we're printing it. Some of the items are integer, string, boolean, which is this true value, and floating point, this is 5. So what is the difference between list and arrays? Arrays are written in NumPy. The whole NumPy module is written in C. Regular expression module is written in C. Some of the kind of modules that are provided within Python, they are written in C for performance reasons, for speed and kind of like, let's just make sure that the data type or all one same type. We call it homogeneous data type rather than heterogeneous like list. list supports like these numbers and characters and string and everything. But again, there's a lot of overhead on the system that has to maintain it, the data structure, the size of the file, and the uh, item, the list that you create, everything grows as a result. So in terms of performance, array of NumPy is much, much, much faster than a list data structure. So, because the data type for each element is homogeneous, it's the same type, not heterogeneous like list is. And also the data is stored into a contiguous area of memory, so it's much faster. I/O read and output, I/O input output, read and write is done really fast. So let's just show you this, and then I'm going to go to the next one. Let's just go with the print statement. So in this case, now I'm going to do a print statement, which I already executed. This one, let me just minimize it. So we printed A. I'm going to print A first here on the cell A, and then we're going to say print type of A. So you could see the differences on those ones. And then at the same time, execute it. Let's just execute this one. You can see now A is an array of 0 through 8 numbers, and then class, the type of it is NumPy dot number of dimension array. And then the data types, information, the attributes that I printed in one line of print statement, you could do a dot shape just to get the shape, and it is a one dimension, and it has 5 elements, so it's 5 comma. And this is just in a tuple kind of data structure. And then the size is 5 elements. And then the item size for each element is 4 bytes long. And then the number of dimension is 1 dimension. And then the type of data type is int32. If you want to define it, you can just define it differently. So like, for example, here on the first example, notice that if I just change this one to 100 and then run this code, notice here that number of dimension, this is very kind of dynamic. So you could just generate this X statement for less comprehension to do 10 numbers, and then, or you could do 100 numbers. So between 0 to 100, it's going to start with 0 and then finish at 98, because that's before reaching to 100. And then the class type, also when we convert it, it is there. And then the number of dimension here is the same. So all of that information that we did, notice here, if I just do 1,000, and then look how big the numbers is. So programming is very easy when you're doing like coding with looping and all these kind of vectorization options. And NumPy is very, very intuitive, very easy to use. And a lot of the scientific community, whether they're using on physics or mathematics or some sort of data science, they use NumPy, Matplotlib, everything for their work, and they are doing awesome work every day, whether they're doing on data science or some sort of machine learning, artificial intelligence, coding, anything. It is good for linear algebra, for a lot of good reasons. You could do these ones. And then notice that right now, if I just change this one to a not equal to, and then let's change this one to 20 numbers, that's between 0 to 20. And then notice that I'm getting the even odd numbers this time, because I said the number not module 2. So when you do these numbers, and I'm going to just go with our initial 10 here, and then just this time I'm going to compare it with um, odd numbers, so not equal 0. You can see that I'm getting these outputs. So let's get to the example why I came back here. and changed a little bit of the code. I'm going to go to the cell here that I was doing on this one. Notice that the cell ran before when the number were even numbers comparison. So now I'm going to just click here and I rerun this test. Now it's going to be odd numbers. And then notice that this time the numbers are there. If I just change this number again to show up to 100 and then run this one, obviously I get those ones. And then let's just go down all the way here to this one and then rerun this one. Rerunning this one, obviously you will get the new numbers and then you can see the type of there. And but some of the information like one dimension is always one dimension because the left bracket and right bracket, that is what it tells it that I don't have two left bracket. There's no two-dimensional array yet. If I just want to change that one, yes, I could do that one. So and the and dimension is there. And then now when we do info.p, this one is almost like a lot of these information plus more. Something that is on Python is called, actually it is the help of Python is very generic. It gives you information about all the Python methods and classes and constraint and double underscore method, under method, exception, everything that you want to operator, everything that you want to do, classes, so objects, you could get help on them. But however, sometimes NumPy modules that are you create like an object like A, an array, or a B, an array, or something, when you create it, if you want details of that one, you cannot do help on A. So that is not going to give you much information because np.info was written in C for this purpose to just give you a lot of the details so that it's already you can print it from this, but you can also get help on it. And this is called universal functions. The universal function is an NumPy. This info will do uh, any help that you can just see on top of the help of that object saying that this is part of the universal function, then you can do np.info on it and get the output of it. So now if I just run the np.info, notice that on those sizes, everything here is doing it. So I'm going to change the number here to only show 10, and then I'll rerun it after there. Let me come back here, rerun it here also. When you rerun it here, you can see 1 to 9, and these numbers that are showing is as a result of a dot shape, a dot size, a dot item size, which is how many bytes per item it is there, number of dimension, and then the data type. D type is the data type. So again, the same information plus more on the np.info A. Plus more meaning that it says that it's a class in dimension array. So this is A is an in dimensional array, as if you're doing like a type A. That information is also there. The shape is 50 comma this. So the elements that are there, you can just actually run it. And then now it's 5 because I just modified it from the big number to smaller number. So then stride is 4, and then item size is 4. And then notice here it says contiguous is true. This is not the case on the case of data structure called list or tuple. They don't allow you to just have uh, the same data type only, and then not supporting multiple data types on the same item or on multiple items of the list. So in this one, it's one data type, which is N32. If you want to get float, you have to define the data type to be float. And if you define it to be type integer, to 16 or 32-bit or 64-bit, you have to specify the size of and data type. So this is what that NP is going to give you a lot of information. And then now I'm going to do a dir. Let me just minimize these windows and this one. I'm gonna move up here. So when you do a dir on A, this is going to just show you all the objects and every classes, everything that is available, other modules that are available on the NumPy. Since we created in P to be an array, A to be an array of NumPy, so A, and then you can see that this is all the methods. These are double underscore methods. Underscore copy, like double underscore copy or contains. If you could check on those ones, they're all similar to the same kind of a dot copy, for example, for the copy. And so some of these double underscore method are called magic method in Python, or double underscore method, or dunder method. They are all available for you to do it. And then on top of it, there's other methods are here with the actual string name, not anything. We covered 6 of these methods last time on Introduction to Python NumPy on tutorial 2, and they were arrays, arrange, zeros, ones, empties, and then info. And then tonight we covered a number of them, including the array, and we're going to cover more of them. Please make sure that you subscribe to our channel so you could watch any of these videos that I post. And from each one of them, I'm making smaller videos now, so you don't have to watch like 2 hours window and then say, oh, I'm not interested on this part. Let me just browse through to look for what I'm looking for. But it is every video is going to be specific to NumPy in this case, and then it's going to just give you a lot of the information here on this. So if you are just interested to get some sort of friend help on A, you could also just do that one. So let's just run this one. And you can see here it does. And the info A was giving you those attributes, but help on the A object is just as if you're doing print on NumPy. This one is the same as NP. So whether you type in A is pointing to the same object that is there. So if I just run that one, let me see why. Okay. So in here, A. Okay. It is maybe rerun it again. Yeah, it is just long. So here, and then and you can see here on this statement, run it, and now we're gonna go here. Sometimes the focus is slower. So let me come back to it. And right here, you can see an PA is telling you the NumPy modules is there. So the output is shown here, all of that. I'm going to minimize that also. So minimize this one. And then go down here. And then minimize this one. And minimize this. So the dir of x, dir of a, dir of a, you saw that dir of and dir of a as this, or dir of NumPy, they were be doing the same thing, whether you do dir a or dir NumPy, and you can see all these methods that are based on that one. So if I do print a dir like this, look, this one is going to give me a list like this long. But if you want a horizontal way in one line like that, You just have to use the print statement. So do a print, and then run it. Now we're getting this. Notice the X, since it's a type of X, it is print type of X. It is actually list. When you do this one, it is showing you it's a list. So it's a list. Notice that all these other methods that are there or associated with list method. For example, you can just pop something from the list or put something to the list or count it or copy it. All these append and insert and index, all of them are specific to those ones. If you want to just learn the less data structure, I have a separate video that is about an hour video long or something. I created those videos for tuple, list, class, and a lot of other data structure. I already covered them, sets, strings, and everything. So please watch those ones for more details, and you're going to enjoy that as well. So this is the type what we did here, and just covering the end of this video, I'm going to come back here what we covered already. So just thanking you for watching. For more videos like this, please subscribe. And my YouTube channel is www.youtube.com at MyWebUniversity. MyWebUniversity is the handle. So you're welcome to just subscribe. And this is the YouTube channel. I already have this one and this one. Last night I posted this one, and it is just available for you. So Python NumPy Module 1 should be watched, and then Num2 and Num3 I'm going to post it now. You should have all three of them and enjoy it and learn from it, and make some comments if you need something additional. If something that you, for example, I put on one of the video that I said do these ones like in the order that I'm listed here, like NumPy. If I'm just doing this here, later on I'm using it. I'm not because I'm inside the cell. It is already loaded. But if you're writing a program from scratch and you just cut and paste a portion of this code, this is not going to understand this one. So don't be kind of like surprised that why printx is not recognized, because you did not have these other statement in the front. Someone made a comment saying it doesn't work. So if you are just copying a portion of it, yes, obviously that is not going to work. Please make sure that I just replied back saying that make sure you import the NumPy as NP. After that one, it should work. I don't know what else you're doing it. If you're writing some kind of description or something, please make sure that I understand your question so I can help you faster rather than just be questioning you on the question itself. Have a nice one. Take care. God bless you all. Bye bye.